So, following on from the last video that focused on the new workshop foundations, this video, as the title suggests, will concentrate on the steel structure. It will show how we went from this model to this. The model was shared with the scaffold team, who then went out and ordered the parts they wanted. Many text messages were sent and many phone calls were made before they knew what was required. Then the rest just happened. I took delivery of the steel, which was a surprise as it did not seem like much of a load. In fact, I thought some parts were missing. But then again, steel is a lot stronger than timber, so you need a lot less, which in turn means it's quicker to put up. If I was making the workshop out of wood, the delivery would have been much, much larger. So I ended up with the poles, some beams, the roof sheeting and a bag of couplings. In this big bag I had scaffold base plates on which the standards will fit, standards meaning the vertical poles. Q-clamps. These enable the diagonal braces to be in line with the standards, therefore they will not encroach into the workspace or into the walls. You will see what I mean in a bit. 90-degree clamps or double coupler. These connect two tubes at 90 degrees and will have a slippage resistance of just under 2,400 kilograms. They are rated to a failure of 5,000 kilograms and a pull-apart force of 5,800 kilograms. So in my book, they are pretty solid and over-engineered for this job. Swivel couplers do what a double coupler does, but allows two poles to be at any angle. They have a slippage resistance of just under 1,300 kilograms. The put logs or single couplers are only designed to keep one tube against another and cannot resist the same forces as the swivel or double couplers. All the tubes I ordered had a standard outside diameter of 48.3 millimeters and a wall thickness of 4 millimeters. These are about as strong as you can get in scaffold tubes. So if you cast your mind back to the delivery of the steel, it was not much, and with two blokes who knew what they were doing, it went up very fast. In fact, it all went up in about 4 hours. If you decide to follow this construction method, make sure the soil is not in contact with the steel, as it will accelerate corrosion, even if the tubes are fully galvanized. Another thing to remember is that doubling up on couplers doubles the slippage resistance. So in a nutshell, that's the permanent frame finished. If you've enjoyed what you see, please like and subscribe. The next video will show how easy it is to work with a steel frame construction compared to a wooden one, as we make some modifications and additions. So, thanks for watching and see you soon.